Welcome back, grade 7 students. I hope you are all doing well and safe at home. Let's continue our lesson about reactants and products. As a reminder, last time we talked about a chemical change. We said that a chemical change affects the identity of a substance where a new substance is formed. We also said that in a chemical reaction, starting substances are called reactants, and the substances that are formed are called the products. We also talked about how the products cannot be changed back into the reactants. Now, we are going to talk about what indicates a chemical reaction. In other words, how do I know that this reaction is actually a chemical reaction? The first indication is a change in color. In this picture, we are adding heat to sugar. Sugar is white in color. After heating, we notice that it becomes light brown, as in the second picture. This change in color indicates a chemical reaction. The second indication that the reaction is a chemical reaction is the formation of a precipitate. In this video, we are putting lead nitrate in the first beaker. In the second beaker, we are putting potassium iodide. Both are clear in color. Then we pour one into the other. We observe a yellow precipitate. The third indication is the production of gas. In this video, we have a cup with ethanoic acid in it, which is known as vinegar. We also are going to put chalk inside it. At the end, we will observe gas bubbles. So, what indicates a chemical reaction? The first indication is a change in color. For example, when we heated the white sugar and it became light brown. The second indication is the formation of a precipitate. For example, when we mix the lead nitrate and potassium iodide to give a yellow precipitate. The third indication is the production of a gas. For example, mixing chalk and vinegar gives gas bubbles. Please pause the video and copy these notes into your copybook. In this video, we have put vinegar and baking soda in a plastic bag on a scale. They weigh 113 grams. As we watch the scale and the plastic bag for the reaction, we notice that the mass remains 113 grams even after the reaction is finished. In the video, we observed that the mass of the reactants, 113 grams, remained the same after the reaction. The mass of the products was also 113 grams. This brings us to the law of conservation of mass, known as Lavoisier's law. During a chemical reaction, mass is conserved. It remains the same, meaning the mass of products formed is equal to the mass of the reactants that have disappeared. Let's solve an example. A sponge with a mass of 100 grams is burned into ashes. Using Lavoisier's law of conservation of mass, calculate the mass of the products. So we know that the law of conservation of mass says the mass of reactants equals the mass of the products. The reactant is the sponge and the ashes are the products. So the answer would be Since the mass of the reactants equals the mass of the products, then the mass of the ashes will remain 100 grams. Alright students, let's solve another question. The dissolution of an aspirin tablet in water is accompanied by an emission of gas, as we can see in the picture. State the indication of the chemical reaction that takes place. Since in the question they say that there is an emission of gas, this would be my indication that this is a chemical reaction. Give the name of the reactant. What reacted in this equation? The aspirin tablet. Therefore, it is the reactant. These are the answers. Copy them into your copybook and then solve the worksheet that we have sent. Hope to see you safe next time.